Hello, welcome back to our little corner on the web, where we go through math problems to hopefully inspire and nurture an interest in math. Today, we will go over questions 1 through 3 of part 3 of the 26 PMO qualifying stage. Question 1, what is the largest prime number which divides 2 plus 2 times 2 factorial plus 3 times 3 factorial plus 4 times 4 factorial and so on and so forth until 2023 times 2023 factorial, all over 2022 factorial. So here, given how the question is phrased, we really hope that the numerator simplifies and cancels out the 2022 factorial, because we're asked for a largest prime number that divides the expression. So that means that it should be that the expression basically should result in an integer. Okay, so with that, we're going to try to see what we can do with the numerator here. So notice just the first two terms. Okay, so we have 2 plus 2 times 2 factorial. So factoring out the 2, we get 2 times 1 plus 2, which is 3 factorial. So putting this 3 factorial together with this term here, we get 3 factorial plus 3 times 3 factorial, which, factoring out the 3 factorial, gives us 1 plus 3. So that is 4 factorial. So it turns out that if we keep going like this, all the terms just folds nicely into each other. And basically, we would have the last thing here to be 2023 factorial, after a while, plus 2023 times 2023 or 2023 factorial, which would be 2024 factorial. So simplifying this expression just gives us 2024 factorial all over 2022 factorial, or that's no more than 2024 times 2023. And it's just a matter of finding the prime factors of 2024, and that's 2 cubed times 11 times 23, multiplied by the prime factors of 2023, which we've done in a previous problem. So that's just 7 times 17 squared. So the largest prime number that divides that expression is 23. Okay, so basically the largest prime factor of that expression. Okay, moving to the next question. Question 2. Tasio is thinking of a 2-digit number. He tells Basilio the 10th digit and Crispin the 1st digit, and challenges them to guess the number. Their conversation goes as follows. Crispin, I know the number is not prime. Tasio, correct. It is divisible by 3. Basilio, now I know what the number is. What digit did Tasio tell Crispin? Okay, so Basilio got the 10th digit. Okay, and Crispin got the units digit. So let's analyze what's happening here in that conversation. So Crispin, with the first statement, says that I know the number is not prime. That means that it should have either ended in an even number or 5. Okay, because if it ended in 1, Crispin cannot claim that it's definitely a prime number, because he might have, the 2-digit number could have been a 31, right? Or some other prime that ends in 1, right? It may not also be a 3, but we have 13, right? 17 and 19. So with the first statement, we know that Crispin could have gotten one of these numbers: 0, 2, 4, 5, 6, or 8. Okay, for the units digit. That's a possibility. And then Tasio gave them another clue with the second statement here. It says, correct, and it's divisible by 3. So put yourself now in Basilio's shoes. Like, oh, it's divisible by 3. Then the possible 10th digit for something that ends in 0 is 369. Possible for something that ends in 2 is 147. Possible that ends in 4 is 258 for the 10th digit. For 5 is again 147. For 6 it's 369. For 8 it's 147. Okay. And if you're Basilio, you look at your number and say, oh, now I know what the number is. Let's see what that means. Okay. If Basilio had a 3, 6, or a 9, he's actually not going to be sure what the units digit is because it could either be 6 or a 0. Same thing for 1, 4, and 7. He's not going to be sure if Crispin actually got a 2, 5, or an 8. But since Basilio shouted out that he knows what the number is, Basilio should have gotten either a 2, a 5, or an 8. We're not exactly sure what it is, but we can now tell because of that the units digit that Basilio got, the units digit that Crispin got was a 4. So the final answer here is that the digit that Tasio told Crispin was a 4, or the units digit was a 4. Okay, so moving on to the next problem. Question 3. Let ABCD be a square and P be a point on segment AB. Segment CP and BD intersect at Q, and BD is extended beyond B to a point S. Finally, T is an intersection of line CP and the line through S parallel to AB. If AB is 18 and PT equals 2CQ, what is the area of the quadrilateral PBST? Okay, so initially when I do this, I do it quite weirdly. I'll try to draw a small figure here on the side. So I just followed its instructions, A, B, C, D, and I picked a point P, so that we now have CP and DB intersecting at point Q. Okay, and we're told that DB is extended out, CP is extended out, but CQ to PT is twice. So T is probably somewhere here where this is, if this is, the length here, this PT is twice that length, and we have S here. Okay, so this was kind of hard to sort of figure out what the relationships between PB, ST, and all those things are. So I said, can we find a corner case, right? Because we do control where P lands. So I ended up drawing another figure. Okay, so I basically made P go to A. So now we had A and P being coincidental, B, C, D, and we have the two diagonals of the square. So if I extend DB, sorry, out, and CP also out, and we want CQ to be half of PT, well, we know that this is also the length. Okay, PT is also the length of a diagonal. Okay, and S here, DS is also a length of a diagonal. That must mean that this height here is also 18, if this thing is 18. Okay. This trapezoid is also an isosceles trapezoid. So we have 18, 18, 18 right there. So that means that we can simply find the area now as 54 the base of the top plus 18, base 1, base 2 plus base 2 over 2 times the height, 18. Okay, so this is nothing more than 36 times 18, which is equal to 648. So the area of the quadrilateral PBST is no more than 648. Hopefully you found these solutions helpful and educational. If you did, do hit the like button and subscribe. Thank you for watching.